everyone, welcome to Mind Brain Talks, the place where you find diverse and scientifically accurate information regarding psychology, psychotherapy, neuropsychology, neurosciences and research methods every single week. My name is Bruno Faustino. I am a licensed clinical psychologist and neuropsychologist who's been working as a therapist, researcher and educator for the past few years. Here, I discuss and describe lots of topics, concepts and theories from psychology to neurosciences, the best as I can for you to understand and for you to learn something about it. So, in this video, I will start to show you how to perform an one-sample T-test. So, without further delay, let's jump for today's content. I used these 4 manuals to develop today's video, and if you want to check them, please see the video's description below where you can find the link to each specific domain, okay? So, let's go. So, one-sample T-test, it's a statistical test that is used to explore if a sample mean is statistically different from a known or an hypothesized population mean. Typically, it's a sample mean that it's tested against a test value, and this test value is an hypothesized value of a mean in the population. This test is considered a parametric test because it has lots of assumptions. And also, one specific thing about this test is that it's not indicated for more than one group, okay? If you want to perform a comparison of a mean value to an hypothesized value, you use a sample test, but to utilize this, you must use only one group, okay? So let's see the assumptions. The test variable must be continuous. It must be an independence of observations. The sample must be collected from random pairing. It is assumed a normal distribution. Also, the homogeneity of the variances is always necessary, and we also have the assumption that can't be outliers in the distribution. So let's go to our hypothetical research problem. Symptomatology tends to be higher in clinical samples than in non-clinical samples. However, this assumption must be explored. Symptomatology, when we talk about symptomatology, we talk about the mean response in a given questionnaire. So we are talking here is that symptomatology is higher in clinical sample than in normal population. Our null hypothesis is the absence of effect, so no difference, and the age one is difference between means. Okay. So now let's jump to the SPSS environment. So now we are here in the SPSS, and we have here our variable symptomatology, and we will test if symptomatology is different from normal population, an hypothesized value of normal population, or not. Okay? So how can we perform this test? We go to here to analyze, compare means, and and he's here, one sample T-test. We click on them. Oh, I've already had selected symptomatology here, okay, but you can just drag it along right here. Okay, so I am using this value. This is an arbitrary value, okay, just to test, and go to options. We have our confidence interval, 95%. Exclude cases analysis by analysis. We can continue. Okay, let's do it. So our output shows that, oh, okay, we look here, okay, this significance level gives us 0.000, which means that we must reject our null hypothesis. So I think that we have a statistical effect when we compare the means of our sample to the hypothesized value of 1.7, that it's a statistical inferences for population. So here we have the t-test, which is less than 17, okay? But here, this is the F, it's the degrees of freedom of our statistical test, but here is the significance of the test. So here we have a significant result, which means that we can now look, first we can look here to our hypothesis. So we can look that symptomatology is higher in clinical sample than in normal population. So there is a significant difference between the means in our sample and that hypothesized value of 1.7, that it's an hypothetical value for a normal population. So we reject the null hypothesis and we accept the age 1 hypothesis. Okay? So I hope that you enjoyed the contents of today, and don't forget to see the video description regarding today's theme to look to the references that I think that are very useful to understand these concepts. Also, if you like what I'm doing here, please consider to subscribe and hit the bell button for notifications. If you want to say something about these topics, please use the comment section below to express your mind. Welcome to the Mind Brain Talks, and I hope to see you in the next video. Bye! Hello everyone! Welcome to Mind Brain Talks, the place where you find diverse and scientifically accurate information regarding psychology, neuropsychology, psychotherapy, neurosciences and research methods every single week. My name is Bruno Faustino. I am a licensed clinical psychologist and neuropsychologist who's been working as a therapist, researcher and educator for the past few years. In Mind Brain Talks, I discuss and describe a lot of topics, research findings and research methods, and I try to explain to you the best as I can for you to understand and for you to learn something about it. All videos here are not intended to diagnose any psychiatric condition or neurological disorder. So, without further delay, let's jump for today's content. I used these 4 manuals to develop today's video, and if you want to check them, please see the video description below where you can find the link to each specific domain, okay? So let's go. Today's content, it will be related to tutorial section, because today I will talk about how to perform paired samples t-test. So stay tuned. So let's see what is a paired sample t-test. A paired sample t-test is a statistical test that is used to explore if means of two conditions from the same object or subject, such as pre-test or post-test scores, are statistically different. It's a measurement of the same observations over different periods of time, such as paired observations. You know, a paired sample t-test, it's a parametric test and explores the statistical difference between two time points, two conditions, two measurements or a matched pair. Now let's look to the parametric assumptions that we must have in mind when we want to perform paired sample t-test. So, the dependent variable must be continuous. there must be dependence of observations, the same group, same subject, same individual, okay? We must have a random sample of data from population. We expect that our data has normal distribution. We expect also homogeneity of variances, and we expect to have no outliers. So now I'll show to you how to apply this knowledge to an hypothetical research problem or research paradigm. Please look to this problem as an hypothetical one, okay? This is not a true problem, this is not true data. I've made this up just to give you some illustration, and I'll show to you how to perform or how to run a paired sample t-test in some random data, okay? Please, this is not real data, this is not real persons, okay? So, let's go. Let's look now for our hypothetical research problem. So, psychotherapy helps to improve emotion regulation skills. However, this assumption must be explored. So, we can transform this research question into an operant condition, such as emotion skills increase after psychotherapy. So, our new hypothesis is there is no difference between a pre-test and a post-test condition, okay? And the age one, our age one hypothesis means that we have a difference between these means. So, as in the other research problems, here we want to reject the null hypothesis, because the null hypothesis means that there is no difference between the pre and the post-test condition. So, if this is true, it means that the psychotherapy does not improve or does not increase the emotion regulation skills. So now let's jump to the SPSS. So now we are here in the SPSS environment, and I'll show to you how to perform or how to run a paired sample t-test. So if you look here, we have our two variables, emotion regulation before a psychotherapy process and emotion regulation after the psychotherapy process. So, how can we perform one sample t-test? We go here to analyze, okay? Then we go here, compare means, and we just choose here paired sample t-test, okay? We click here, and then this box will show. On the left we have our variables, and we will choose the variables that we want to compare. So it's emotion regulation pre, go here, and emotion regulation post. It will go to here, okay? We look to options, we just leave the standardized values that the SPSS gave us, 95%, and to exclude cases, analysis by analysis, okay? So also, it's pretty simple to perform this test. Then we just click OK. So what we have here? We have here these tables, okay? In this table we have the mean from the first variable, the n, and the standard deviation. Then we have the other mean for the second group, okay? The second mean, the second observation. This is 3.5 and 4.1. So here we have a paired sample correlation, which means that there is a significant correlation between this pair, okay? It's a correlation at 0.61, and as you may see, the significant value is below 0.01 or 0.05, which means that this correlation is significant. And here we go to the third table that shows us if there is a statistical significant a difference between the first mean to the first mean. So here we have the difference, okay, and the standard deviation. Here we have the confidence intervals that we have for our difference. Here we have the value of the t-test. Here we have the degrees of freedom. And then finally, here we have our significance for our paired sample t-test. And as you may see, this value is below 0.01 or 0.05, which means that the difference between the first mean and the second mean is significant. Therefore, we may imply that the psychotherapy may increase or may boost or may develop neuroregulation skills which may be object or may be identified by paired sample t-test. Okay? So, again, here we have your difference between means, the standard deviation. This is the standard error, okay? So here we have the lower confidence interval and upper confidence interval, the two margins, okay? Then we have here the t-test, the value of t-test. Here you have the degrees of freedom, and here you have the significant value, which means that the difference between the first mean and the second mean is significant. So, I hope that you enjoyed the contents of today, and don't forget to see the video's description regarding today's theme to look to the references that I think that are very useful to understand these concepts. Also, if you like what I'm doing here, please consider to subscribe and hit the bell button for notifications. Also, if you want to say something about these topics, please use the comment section below to express your mind. Welcome to the Mind Brain Talks, and I hope to see you in the next video. Bye!